Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you doing today? Hoping all of you are having a great day today. And first of all, I would like to thank you for being here again today to watch and listen for the final two sections of Polymorphism chapter. We will be learning a new subtopics on the protected data and methods and how to preventing, extending, and overriding in a program. Right. Right. First of all, what do you know about protected? In Java programming, protected is a modifier type other than public and private that can be applied on a data and methods in a class. In comparison to public and private, protected data or methods in the public class can be accessed by any class in the same package, and it also can be accessed by its subclasses even if the subclasses are in the different package. Sounds like a bit complicated, but believe me, it is simple and straightforward. The following diagram down there, okay, illustrate the visibility comparison between private, protected, and public. If you think that you are constructing a common and basic program, then the rule of thumb is easy. Public modifier will be the ideal choice for you to ensure that no issue will be raised for accessing information in the program. The next following slide summarizes the access grants for every visibility modifier in a program that might be in the same class or classes in the same package with inheritance associations, which is a subclass, classes in the same package without association, and classes in different package and with and without association. A field or method that is not declared as public, private, or protected can be accessed by all classes in the same package, which is usually not desirable. Sometimes we did this in practice, and perhaps you could improve your program by providing this visibility modifier in your program in the future. Seems a bit challenging to understand. However, the next slide will give you much clearer view on the importance of what we are discussing right now. Okay, the following incomplete Java program example illustrate the best representation to summarize the visibility modifier that we have discussed in previous slide. From this example, I believe each of you is able to implement a complete and executable program that will allow you to observe and understand the full concept of modifiers. You may try to construct your own program by following the given example. Observe your program and look how significant is every modifier in your program. From the program that you have constructed from a previous slide, it can be clearly observed that a subclass named C3 may override and invoke a protected methods in its superclass named as protected void M methods and change its visibility to public. However, a subclass cannot weaken the accessibility of the M method, which defined in the superclass. For example, if a method defined as public in the superclass C1, it must be defined as a public as well as in the subclass of C3. If you still can remember the concept of extending and overriding in inheritance, then I am pretty sure this topic will become easy for you. Okay, guys, we have additional notes in the next slides mentioning that the modifier are used on classes and class members that is data or variables and method, except that the final modifier can also be used on local variables in a method. Other than public, protected, and private, final local variable is a constant inside a method. The main purpose of defining a final modifier is to fix a value of a local variable that is constant in a program. Since a final modifier is to describe any class or local variable that is fixed and constant, then the final cannot be extended by any other class to avoid any overriding attempts. Besides, class like math and local variable like pi is a final method also fixed and cannot be overridden by any methods in its subclasses. Right, and now we move into the final section of the chapter, which is an approach to preventing, extending, and overriding in specific program with inheritance association. In general, there are three specific methods for you to learn in this section, namely finalize method, clone methods, getClass method. The finalize method is invoked by the garbage collector on an object when the object becomes garbage. The clone method copies an object that is the same state as an existing object, and the getClass method will return an instance of the java.lang.class class, which contains the information about the class for the object. Right, in finalize method, it is invoked by the Java virtual machine, and you should never write the code to invoke it in your program. Thus, the protected modifier is required and appropriate in use. Let's look at examples of the program. Right. The given example illustrates finalize method implementation, which consists of two classes, namely finalization demo class and cake class that extend object class. By looking at the main method class in finalization demo, the program constructs three cake objects A1, A2, and A3 with different value of ID. You can refer this as the constructor method in cake class. After all objects were constructed, the program tries to delete two objects, which is A2 and A3, by pointing them to the null. And by now, A2 and A3 have becoming as garbage. Upon this operations, the program will execute system.gc garbage collector method, that is the garbage collector to clear up the space used from the memory. At the same time, Java Virtual Machine will invoke the finalize method by default after detecting objects become garbage and print out the necessary output. There will be the output of your program. Alright. And now we look into another program example. This time we take into account an instance method, and which commonly used in most programs you have built before, and a static method. What is the difference between instance and static method? Firstly, you can simply override an instance method from a subclass, but not a static method. If you declare a static method in subclass with the same name as one in the superclass, the one in the superclass will be hidden, but it still exists. To demonstrate this in a better view, we look at the given example in the following slide. The program called hiding demo consists of two classes, namely class A that is reacting as the superclass and class B as a subclass that extending class A. As you look into both classes, you could observe that the instance variable I and a static variable j. There are also instance method in both classes, which is public string m2 method, and also static method, which is public static string m1 method. The implementation of the program will demonstrate the difference between those variables I and j and methods m1 and m2. In order to trace the program, you may look at the main method, and there is a statement of object creation called X. What is interesting here is that X was defined as an object that belongs to class A, but it is a type of class B. Then the preceding statements will manipulate the X object that to access the variables of I and J and methods M1 and M2. For this example, I will encourage you to implement it in your own Eclipse editor so that you may trace and focus for each statement in the program. Most importantly, you have to observe how X can access instance variable or methods and the static variables or methods. Both instance and static modifier have a very clear implementation, and you should be able to state their difference. Execute the program and trace the remaining output from the main method and try to summarize your finding. This is the class B and class A. And this will be the output of your program. Okay guys, we have reached the final topic in the polymorphism chapter, which is initialization block. Okay, so what is initialization block? It is a specific feature that can be used to initialize object along with the constructor. It is a body of a statement enclosed inside a pair of braces or curly bracket. Initialization block appears within the class declaration but not inside any methods or constructor. The initialization block will be executed as if it were placed at the beginning of every constructor in the class. The following program example illustrate the way on how initialization block can be written in more specific way as compared to the traditional or common program. Initialization block can also be declared as a static so that it can be only referred to as static members of the class and being invoked when the class is loaded by the Java virtual machine. To get a better illustration, there is a program example for us to observe and implement. Altogether, there are 3 classes in the example. Alright. And you may observe class N as the superclass extended by its subclass class M. Alright. In each class, there is a common initialization block and another one that is declared as a static initialization block. Bear in mind, in each class also has a constructor. Now we look at the main method in initialization demo class, where we should start the execution from here. It is very clear that the program is constructing a new object called object that belongs to class N and a type of class M. Upon of this object creation, the program starts to execute the constructor of class M and class N. It is good if you can implement this program in your Eclipse editor and focus how the program is executed and how the output could be generated by traversing all constructor in the program, and finally you should be able to summarize the implementation of initialization block for both common and static type. Find the significance and spot the difference between them. Alright, so that will be the output of the program. Okay, that will be the end of our topic for today. I will encourage you, all of you, to do all the examples and hands-on in the slides for better understanding. There is no shortcut in learning programming other than doing examples, exercise, and all of your efforts in the practice will make your knowledge on programming nearly to perfect, inshallah. Thank you guys for watching and listening. Till then, take care and stay healthy. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.